So let's discuss a topic from mathematical physics, that is gamma function and its properties in this video. So here is the beta function and gamma functions definitions. So the gamma function and beta functions belong to the category of special transcendental functions. So these are the special functions, transcendental functions, and are defined in terms of improper definite integrals, and they would have improper integrals. These functions are very useful in many areas like asymptotic series, Riemann zeta functions. So these are the functions which we make use of in asymptotic series like Riemann zeta function, number theory, etc., and also have many applications in engineering and physics. So that is about beta and gamma functions. Now let's see gamma function. So the gamma function is denoted by gamma n. So here the symbol is given. So gamma function is gamma n. So this is nothing but gamma function. So this is the symbol used to denote gamma, not like alpha, beta, gamma. So this is different. So where n is greater than 0 and defined by a definite integral. And here another important condition is n must be greater than 0. That means n is a positive value but not a negative value. So the definition of a gamma function is given here. So this is nothing but gamma n, which is equal to integration of 0 to infinity e power minus x into x power n minus 1 dx. So integration was 0 to infinity e power e raised to the power of minus x, exponential term multiplied with this x power n minus 1 dx, and n must be greater than 0. This is important condition. So this is the definition of gamma function, and based on the definition of this gamma function, we are having the properties like gamma 1 is equals to 1. That means in the place of n, if you place 1, we used to get 1. So in the same way, gamma n plus 1 is also n into gamma n, that is nothing but root n, that is factorial n. This is another property which would be proved now. So another thing is gamma n could also be written as z power n into integration 0 to infinity e power minus zx x power n minus 1 dx. So this is another form of gamma function. And next another form is integration of 0 to 1 log of 1 by y whole power n minus 1 dy. This is another form of gamma function, and these are all also the properties of this gamma function. And again, in next thing is gamma of n plus 1 is equal to integration of 0 to infinity e power minus y. So e raised to the power of minus y, and this y raised to the power of 1 by n. So that is the thing, and whole into dy. So this is another property. And next is gamma half. Gamma half is nothing but root pi. So these are all the properties of this gamma function. Now let us see these properties proof. So this is the first property, that is gamma 1 is also 1. How is it possible? Means by only making use of the definition of gamma function, that is gamma n is also integration of 0 to infinity e power minus x power n minus 1 dx. Now gamma 1 is nothing but n replaced with 1. In the place of n we need to replace with 1. So gamma 1 and has x power 1 minus 1 is 0. In the place of n we are writing 1. So 1 minus 1, that is nothing but x power 0. So that is nothing but 1. So finally what would remain is only e power minus x. So integration of 0 to infinity e power minus x dx. Now integrating this, what we get it, this is of the form e power ax, integration of e power ax, that is nothing but e power ax by a, e power ax by a. If we do integration, so e power ax by a, so here in the place of a, what is there means -1, so e power minus x by -1 and next we need to apply limits from 0 to infinity. So one thing we can do is here we could take -1 common from inside, so -1 has been taken common here, and next applying limit e power minus, first of all e power minus infinity minus e power minus 0, so e power minus infinity is nothing but 1 by e power infinity, and we know that e is something 2.7 some and so on. So that one, that power, that thing rise to infinity is nothing but 1 by infinity, again we would get infinity, and 1 by infinity is nothing but 0, hence we are having 0 here. And next thing is upper, that is the upper limit minus lower limit e power minus 0, e power minus 0 is nothing but e power 0, e power 0 is nothing but 1, so that is the thing. And next thing what we are having is, so -1 into 0 minus 1, that is nothing but -1 into -1, that is +1, so we have +1. So this is the first property, that is gamma 1 is equals to 1. Now we need to prove the second property, that is gamma of n plus 1 is equals to n gamma n, so that one we need to see. So again we need to use the same thing, that is the definition of gamma function. So from the definition of gamma function, gamma n is integration of 0 to infinity e power minus x, x power n minus 1 dx. Now as here we are given gamma n plus 1, which is written in the form of n gamma n. So now here what we are doing is n is replaced with n plus 1. In this equation n has to be replaced with n plus 1. So if we do so, what would happen is, so here you can see e power minus x would remain the same, x power here in the place of n plus 1, n plus 1 is written minus 1. So n is replaced with n plus 1 because we need to find gamma n plus 1 in terms of gamma n. So after being replaced whole dx, and n plus 1 minus 1, 1 would get cancelled and n would remain. So hence we are having equation of 0 to infinity e power minus a x power n dx. And next thing is we need to integrate this, it is of the form integration of uv dx. So we need to apply this formula now. So integration of uv dx, so which is so integration of uv dx. So here we need to make use of the condition I let, so which is u and which is we need to decide. So first of all we need to take this is the order of taking. First in the place of u, what we need to take is whether it may be inverse, logarithmic, algebraic, trigonometry, and last one finally exponential term, mostly it would be v. So here x power n is nothing but algebraic term. So first we need to take x power n has u, so in this x power n is equals to u, and v is nothing but e power minus x. So that is the thing, and the formula is nothing for this is nothing but u. So this integration formula is u into integration of v dx minus integration of v dx. This is u into integration of, so v dx minus integration of d by dx of u, integration of v dx whole dx. So first we need to differentiate u term, and again we need to integrate v dx just as we do here, and the result has to be integrated again. So this is the formula. We need to apply this formula. So that is the thing we have to do here. So based on this, so in the place of u we are having x power n. So u is nothing but x power n into integration of v dx. V is nothing but e power minus x. So if we do integration of e power minus x, we would get e power minus x by minus 1. So that is the thing here it is written. So next is we need to apply limits from 0 to infinity minus integration of d by dx of u. This is d by dx of u, that is d by dx of x power n, n into x power n minus 1. Next into integration of v dx, that is same as here, integration of v dx e power minus x by minus 1, and this entire thing has to be integrated once again based on the formula. So that is the thing. And next here if you see interesting thing is now we need to apply limits for this term. So if we see upper limit, while substituting upper limit in the place of x, when x is replaced with infinity, here we can see infinity power n into e power minus infinity. So infinity power n is infinity, e power minus infinity is 0. 1 by e power minus infinity is nothing but 1 by infinity, that is nothing but 0. So first limit would be 0. Next upper limit minus lower limit. So in while substituting for the lower limit, so in the place of x 0, so 0 power n into e power 0. Of course e power 0 would be 1, but it is multiplied with 0 power n. 0 power n is nothing but 0. 0 into anything is 0. So this term would be eliminated. And next what would remain is this. So in this n is the constant. So it has been taken out, integration of 0 to infinity, and here 1 minus is there, here already outside minus is there, so minus into minus plus, and integration of 0 to infinity e power minus x, so this is remaining here, into x power n minus 1 dx. So finally we would have this. So here gamma n, this is nothing but gamma n. This is the formula for gamma n, integration of 0 to infinity e power minus x, x power n minus 1. That is here you can see e power minus x, x power n minus 1 ex. So again we are getting gamma n here. So which is nothing but n gamma n in the place of this. So n has been taken out to be constant. So n gamma n plus 1 is nothing but equal to n gamma n. And next thing, in the similar fashion we can write gamma n here. So keeping this n aside, this gamma n could be written as gamma n minus 1 into gamma n minus 1. So just like here, gamma of n plus 1 is there. So what we did here, in order to get n plus 1 must be subtracted with 1, n plus 1 minus 1, that is nothing but n. So hence we are having this n gamma n. In the similar fashion, gamma n could be written as this. Gamma n is nothing but n minus 1 into gamma n minus 1. Next, what these two would be taken aside. So n into n minus 1. Next, gamma n minus 1 could be written as n minus 1 minus 1, that is n minus 2, gamma of n minus 1 minus 1, that is gamma n minus 2. So this formula needs to be applied repeatedly. We are applying this formula repeatedly. If we go on applying this formula, so finally where we will stop is here, gamma 1, that is 2 minus 1 gamma 2 minus 1. So finally we would stop, that is nothing but gamma 1. gamma n 1 it would end, and we already know that gamma 1 is nothing but 1. Here it is given, so gamma 1 would be 1. So finally what we are getting is, if we see here, 1 into 2 into 3 into and so on n, that is nothing but n factorial. N factorial is nothing but n into n minus 1 into n minus 2 and so on until 3 to 1. So finally we will have gamma of n plus 1 is nothing but factorial n. So this is the proof for the second property. And so next thing is, we need to prove the property gamma n is equals to z power n integration of 0 to infinity e power minus zx x power n minus 1 dx. And we know from the definition of, again we need to use the same, that is the definition of gamma function. So gamma n is equals to integration of 0 to infinity e power minus x x power n minus 1 dx. So here what we need to do is, in the place of x we need to replace it with zy. So x is nothing but zy, some constant multiplied with y. So if we do differentiation on both sides, differentiation of x is nothing but dx, and differentiation of zy is nothing but z dy. So we are not using here uv form because here z is nothing but taken to be constant. So this is the thing. So in the place of x, so in this equation, in the place of x we need to substitute this zy, and in the place of dx we need to substitute z dy. So here we can see it. So in the place of x we have substituted zy, here also zy whole power n minus 1, and in the place of dx z dy, so we have substituted it. And another thing is, we need to look at the limits. So here 0 is the lower limit. So when x is 0 is equals to zy, 0 by z is nothing but again 0, so y would also be 0. As this is a function of here dx is there, here dy is there. Now next if we place, in the place of x if we write infinity is also zy. Infinity divided by constant is also a infinity. Of course it is reduced one, but it is also again the infinity. So y is nothing but infinity. So upper limit also would not change. Here lower limit and upper limit would not change in this process. And so next thing is, so we have substituted all of them along with the limits. Now this is nothing but z power n minus 1 into y power n minus 1. So y power n minus 1 would remain inside. Here z power n minus 1 into z, that is nothing but z power n minus 1 plus 1, that is z power n, and it is taken outside here because it is considered to be some constant multiplied with y. So e power minus zy would remain the same and dy would remain the same. So here if we see, this is of the form, and this equation, this part is of this form, this integration of 0 to infinity, integration of 0 to infinity, e power minus zy, here also e power actually here what we are doing is replacing y with x. Actually in general x is nothing but z into y, but for simplicity, as here gamma function is written in terms of x, here it is in terms of y. Of course we can stop here itself, but as everywhere it is written in terms of x, so here also in the proof it is written in terms of x. So we simply need to replace y is in the place of y x. So e power minus zy is nothing but e power zx y power n minus 1 x power n minus 1 dy dx. So this is the thing. Actually here should not be confused. X is nothing but zy. That is the only change we have made here, and y is not y. If we want rate according to this, that is nothing but x by z, but we are just replacing the y letter with x letter, that's it. you are not doing. So we might write e power ax or e power ay or e power az. So we can represent this function whether in x or y or z. Same function could be represented. We need some variable that will let it be x, let it be y, let it be z, like that. We have just here it is in terms of y, that one we have changed it to in terms of x. That's it. So this both are same. So this and this are the same. Only thing is in the place of y we are using x here. So this is the proof of next one. And now coming to the next property. So again, so we need to prove this log of 1 by y whole power n minus 1. So from the definition of, again we need to use the definition of gamma function, that is gamma integration of is equals to integration of 0 to infinity e power minus x power n minus 1 dx. So here if we see clearly, here also it is logarithm power n minus 1. Here x power n minus 1 is there. So clearly from this we can say that x is nothing but log of 1 by y. So from this we need to prove this. So clearly observing we can see that, we can say that x is nothing but log of equal to log of 1 by y. Now we need to send this log to this side. So if we send it, it would become e power x, and 1 by y would remain like that only. Next we need to send this y to that side, and this ex to, we need to bring it to this side. So here it is dividing it. If it goes there, it would become y into e power x. Again y is also 1 by e power x, and 1 by e power x is nothing but e power minus x. Now differentiate, we need to do differentiating on both sides. Differentiating y, we will get dy is equals to differentiation of e power minus x is nothing but minus e power minus x dx. Differentiation of e power x is just e power x, and differentiation of e power minus x is minus e power minus x dx. That is differentiation of e power ax is a e power ax. And next thing is, now we need to look at the limits. So this is the important thing here. We must while we are substituting, we must keep the track of limits in the case of integration. So as y is equals to 1 by e power x, so when x is 0, so here lower limit is 0, so what it would become, 1 by e power 0, 1 by 1, so y is equals to 1. And when x is equals to infinity, 1 by e power infinity, that is 1 by infinity, that is y is 0. So here you can see the 0th limit has been replaced with 1 here, that is the lower limit, and the upper limit infinity has been replaced with 0 based on this calculation. So here it is 0 to infinity, here it is 1 to 0, and in the place of x, log of 1 by y whole power n minus 1, and next thing is here dy, in the as dy is nothing but minus e power minus x dx. So here if we see, we have replaced x power n minus 1 by log of 1 by y whole power n minus 1, and this limits also we have replaced, and what is remaining here is e power minus x dx. This is the thing remaining, but we know that e power minus x dx is equals to minus dy, so hence we have kept presented here minus dy. And we know that integration of a to b dx is nothing but minus integration of b to a dx. That means if we change the limit, lower limit to upper limit to lower limit, signs would be changed. So this minus is taken into this integration, so it would become 1 to 0 integration would become 0 to 1 integration here, based on the change of limits property. On changing the limits, on changing upper limit to lower limit to upper limit in integration, So we would have this kind of minus integration of a to b if we do, and again integration of a to b dx is nothing but minus integration of b to a dx. So like that, based on that, this minus sign would get eliminated, and here limits have changed again because this minus sign has been grasped into this integration. So here we are doing 1 to 0, but here it is 0 to 1 based on the integration rules. And next thing is, so this is the thing, final thing we are having. Finally we will have this. So this is the thing we wanted to prove. So finally we have proved it. So next thing, now coming to the final property. So another property. So by definition, so we need to prove this. This is the thing we need to prove. Gamma of n plus 1 is equal to integration of 0 to infinity e power minus y 1 by n dy. So we know from the definition of gamma n, this is the definition of gamma n, integration of 0 to infinity e power minus x power n minus 1 dx. Now in the place of y x, we need to put y power 1 by n. So here you can see clearly e power minus x, in the place of x, it seems like it is replaced with y power 1 by n. So hence we have replaced with y power 1 by n, and we need to take taking power whole to the power of n on both sides. If we do x power n, here x power n we will get here y whole power 1 by n whole power n, that is y. And now what we need to do is differentiating on both sides. So differentiation of x power n is nothing but n into x power n minus 1 dx, here dy, and this n has to be sent to this side. So on sending that side, it would become dy by n, and here again there is no change in limits. So we need to cross check this point. So when x is 0, so actually x power n is equals to y. So if x is 0, 0 power n is obviously 0. So y is also 0. So there is no change of limit here. And now coming to infinity, when x is infinity, infinity power n is again infinity. So y would become infinity. So there is no change of limits in this according to this. And next thing is, as x has been replaced with y power 1 by n, so e power minus x y power 1 by n. And next thing is x power n minus 1 dx. So here also we are having x power n minus 1 dx. So it has been replaced with dy by n, simply here. So dy by n, and this n which is present here is a constant, so it can be taken out of the integration. So we would get 1 by n multiplied with this integration of this term 1 by n multiplied with integration of 0 to infinity e power minus y whole power 1 by n dy. So this n has to be sent to this side. So on sending it to this side, we would have n gamma n. So n gamma n is equals to integration of 0 to infinity e power minus y whole power 1 by n dy. And we know that n gamma n is nothing but gamma n plus 1. Based on the second property, I think. Yes, is based on the second property. So gamma n plus 1 is also n gamma n. Now only we have proved it. So you would have here gamma n in the place of n gamma n, and this is as usual. So these are the properties and their proofs. So that's all about gamma function and its property. So this is all about gamma function and its properties. So thank you.